Hi, I'm Octopyte and this is how I created my RC car. A long while ago, I decided that I wanted to make an RC car, and I did. To a certain point, my old design worked, but it wasn't great. And about 4 months ago, I started my projects from scratch. I quickly modeled all my electronics and bought some new wheels. One big problem that the previous car had was that it was cogging, meaning that the motor wasn't strong enough to push off the car by itself. So, to fix this, I could have either gotten a lower kV motor, which would increase the torque, or, in this case, what I chose, increasing the gear ratio. So, I used a gear generator plugin in Fusion and created the 6:1 gear ratio. If you're wondering what settings I used for the creation of the gears, the simple answer is I kinda just chose random values and looked at what looked good, instead of what probably would have functioned better. I also chose double helical gears. These gears would have great efficiency, no axial force, and would be quieter. Big goal for the project was to create good suspension that would be able to drive on bumpy roads, and I sort of did that, but as you'll see later in the video, it didn't turn out as well as I expected. Once I finished creating the housing around the gears, my next step was to create the arms. These arms were designed by making 2 sketches, which would create the 2 profiles needed to create the arm. Having these 2 sketches would mean that I could make the model fully parametric and adjust it based on my needs. For this project, I created double wishbone suspension as it allows the wheels to stay perpendicular to the ground at all time. To do this, you need 2 arms on both sides and an attachment between both of these points. So, with a bit of Fusion magic, we can mirror the arms on each side and create some hub mounts. With it all printed out, it should look something like this. Now that I had completed the suspension, I needed some kind of transmission between the gear and the wheels. I had a few options to do this, like universal joints or CV joints. However, they were both too complex for 3D printing. So, I sort of came up with my own way, and this is how it turned out. The key things I needed to keep in mind when designing this were having the transmission parallel to the suspension arms. The joints themselves work similarly to CV joints, where they have free movement in the X and Y axes, but still retain the rotational torque needed. The front build is essentially the rear build, just with a few extra joints. The first joint I had to add was here, so the wheels could turn left and right. I also ended up spending an unnecessary amount of time working on Ackerman steering. However, I would later find out that it would have a very small effect on the steering. The purpose of Ackerman steering is to prevent slippage. It does this by making all the centers of rotation at one point. We can achieve this by making all the steering points lie between the wheels and the rear. Similarly to the transmission, we also need the steering linkages to be parallel with the suspension arms. We do this by having them be at the same length and also at the same offset on both sides. The final step was connecting the 2 parts together. I did this by making a long extrusion and cutting out a place where the screws can be placed. And after this, my project was complete and I could start testing. I used my Bambolab A1 Mini to print out all my parts, and then I collected them and with a bit of magic, I assembled them. Before I go into showing the car, I want to say that this thing is nowhere near perfect, but I don't have the brain power to fix everything wrong about it. So, this is what you get. It's not perfect, but it's only my second attempt. Who knows, someday I might revisit it.